All right, hello everyone on YouTube and on Zoom, and hi everyone in the classroom. It is our final seminar. Hopefully it's not our final semester. To get the recording going here and record to the cloud. You should just got it over there, Krista. All right, so this week is our last seminar, and we're very lucky to have with us Dr. Krista Court. Krista is a colleague, partner on a lot of projects. We've been working together, and it's a real pleasure to have her here. So thank you, Krista. Dr. Krista Court is an assistant professor. Like, I don't know how still an assistant professor.
It goes in.
Okay, so soon, so to be associate professor of regional economics in the Food and Resource Economics Department at UF and the Institute of Food and Cultural Sciences, IFAS. She also serves as director of the UF IFAS Economic Impact Analysis Program, which conducts regional economic analyses for a wide range of projects. So Chris is on the news a lot because everyone wants to know, when a hurricane comes in, what were the damages to the ag sector? When red tide comes, what were the damages to the tourism sector? If we're really going to save water quality in the state and we need to change how we live, what is that going to cost? So everyone wants to know from Krista, what's it going to cost? Her research interests include disaster impact analysis, regional economic modeling, economic impact analysis, and connecting human and natural systems. She's got a ton of projects, ton of accolades, ton of pubs, and actually I learned that you have an undergraduate degree in Spanish. But she's asked us to never ask her anything in Spanish because she's forgotten all of it, as well as a master's and PhD in economics from West Virginia University. So that, Krista, the floor is yours.
Thank you very much, David. I'm very happy to be here. This is aside from conferences, the second in-person seminar. So it's nice to be back in person and see people, not just faces on the Zoom, but we're happy to have the people that are on the Zoom as well get used to this. So I was asked to talk about water because we're in water wetlands and watershed seminar. And one of the things that we do that sort of connects disaster impact analysis, regional economic modeling, and water is our work on harmful algal blooms. So we've recently finished or are finishing up several projects that have been externally funded over the last 3 years. And I figured I would just give you a brief glimpse of a lot of things that we learned or are still learning from those projects as an overview here. So I don't have that many slides, and I'm happy to take lots of questions at the end if we don't fill up the full-time slot. But we have a very large team. So I'm essentially the figurehead on a lot of these projects. Dia put the proposal in, but then we have a lot of graduate students, postdocs, other collaborators, faculty colleagues, as well as extension colleagues, and stakeholders even outside of the university that work on this one. So I always like to thank them at the beginning of this, and I'm happy to connect you with certain individuals if you have questions that I can't answer. And we've got a range of funding for these projects. So as David mentioned, not only does the news media call me often, but industry stakeholders call and say, we need information so that we can go to the policymakers if we feel like there is something that should be done about a lot of these problems. So we have industry funding for some of this work. We have some of the traditional regional or national level external funding agencies, and we've had some support from Florida Sea Grant over the years, especially in terms of helping students travel to talk about the results of this research. Little bit of motivation here. So with harmful algal blooms, if you're not familiar, harmful algal bloom is one that algae that produces toxins that are harmful to either the environment or humans. And a lot of the policy discussion around these, it kind of hinges on 3 things, right? The existence of the harmful algal bloom, and the probability that it will recur. The exposed human population. So there you have the probability of exposure and policies that could potentially reduce exposure of that human population. And then whether or not there's actually impacts, right? You could be exposed, but maybe not fallible to the impacts of some of these, whether it's health or economy. So we've got the probability of impact and mitigation of impact. So where we work is typically in this last square, looking at trying to quantify those impacts, so that not only we provide information here, but we're providing information to whether or not, if we decide what's it going to cost to reduce exposure or to prevent a bloom, then we know, is it worth it, depending on what those impacts to the human population was. So I'll argue here that the accurate and defensible estimates of the socioeconomic impacts of harmful algal blooms can inform a lot of these discussions that are surrounding any of the measures or policies that individuals or policymakers are aimed at decreasing the frequency or decreasing the intensity of harmful algal blooms and or mitigating their consequences. All right, setting the stage for this particular talk, I sent in a title that included known knowns and known unknowns, right? And this comes, it's a relatively well-known framework, but what we're looking at is, our own knowledge about the impact of something, as well as knowledge about the occurrence. So you have 4 quadrants here. You've got known unknowns, and these are the things that we know are there, but we can't predict them. We don't know enough about them yet. Known knowns are the things that we're relatively certain of. We still have unknown knowns, which is other people know these, right? So this could be like a policymaker sitting around knowing what they might do about harmful algal blooms, but I don't know as a researcher what's going on in their heads necessarily until we do it. And then you've got unknown unknowns, which is we don't even know that we don't know. And I'm sure there's plenty in these complex issues of unknown unknowns, but I'm going to focus on these first 2. So again, after 3 years of research, or even before we started, what were the known knowns about harmful algal blooms and the known unknowns? So if we think about known knowns with respect to red tide in Florida, and I made a major faux pas when I originally sent in the title and called it Florida red tide, and we should never do that because it's not specific to Florida. And I'm not talking about a particular red tide that only happens in Florida. It's red tide in Florida instead of Florida red tide. These are naturally occurring events. They're caused by the merino dinoflagellate Karenia brevis. Karenia brevis produces brevetoxins, and that's what makes it a harmful algal bloom and can impact both ecological systems, human health, as well as human activity. So this creates hypoxic zones. So fish die, fish can move so that they're not in these hypoxic zones. The toxins can accumulate in filter feeding organisms, so like shellfish, whether we've got shellfish aquaculture out along the coast of Florida, or just wild shellfish harvesting. It can affect human health, so you can get, I don't know if anyone has personally experienced it, but you can get eye or skin or respiratory irritation when these red tides are intense enough. And it can include gastrointestinal upset if you happen to eat some of the shellfish that have accumulated enough of this toxin. And the type and the severity of these effects are dependent on how you were exposed and the length of your exposure, or even the intensity of the amount of organism that you were exposed to. And we know that red tide can affect human activity and the economy, but a lot of this evidence up until maybe a decade, 2 decades ago was anecdotal. We didn't have a lot of good information quantifying what those impacts to either human activity, human behavior, or the economy was, because most of the research was focused on those human health impacts. So the known unknowns with respect to red tide, and this is just a small portion of them, but we know, but we don't know enough about the influence on human activity on red tide events, right? So there is potentially climate change driven temperature rise. It's changing the temperature of water, changing where these events can occur and potentially how intense they are, or the scope of the event and the duration of the event. We also know there's human influence on nitrogen and phosphate levels in coastal areas, and I'm pretty sure we've got another outcome of a recent project that I need to add as a literature source there. But we know that humans are influencing these nutrient levels that are impacting, again, the intensity or the scope of these harmful algal bloom events. We also know there's an influence of red tide on human activity, right? So, but what we didn't know, or what was unknown about these knowns, was which activities are impacted, how are they impacted, and then what are the resulting impacts even on the broader economy of some of those behavioral changes. So this is where we focused for the last 3 years, and I'll be honest with you, a lot of the proposals that I wrote basically said, we'll try to do anything with any of the data that we can get our hands on, because this is just so ripe for investigation, but there's a lot of difficulties in quantifying. So again, difficulty in measuring socioeconomic impacts. So these events, it's not like a hurricane. A hurricane comes through, I know exactly which areas of the state were impacted. I can often collect very spatially disaggregated data on what kind of wind particular area, how much precipitation did it get, or precipitation intensity over that event. It's the flooding. But with the harmful algal bloom, they're often transient, right? These are dynamic events. These dinoflagellates are moving around. It's rapidly evolving. It can change, the conditions can change day to day or even hour to hour on a particular beach. And these dynamics of the bloom are really key for both those impacts to the marine environment, but also economic impacts. And then I like to remind people that humans are not marine life. We don't react the same way to a red tide event. And we all learned that during COVID-19, right? We had some information. We thought we knew what people would do with that information, and all hell broke loose. And people don't behave like you expect them to behave all the time. But all of this makes it really difficult. So this chart is just showing that the transient or the dynamic nature of a harmful algal bloom. So the size of the circle is showing the ratio of the water samples in a particular county that was above the threshold of red tides. It's 100,000 cells per liter. And we're going over time here. The higher it is on the bar chart there, it's the number of samples that were collected above that threshold. So you can see that some counties are consistent over this 2018 event. Some counties kind of went up and down, and those impacts were different within the shoreline of those counties. Well, with respect to data and modeling, there's a lot of limitations for socioeconomic analysis specifically. So the temporal and geographical limitations on data related to the size, the scope, the intensity of the bloom itself, which is not things that the economists are coming up with, but it's data that we need or modeled results that we need in order to say where the event was, how large was it, how long did it last. We get some of that right now from in situ sampling. It's also paired with information on from remote sensing or satellite data. And even now we're starting to get data from machine learning or artificial intelligence approaches that put all of that together and sort of predict where the event is and how intense it is. But it's really difficult to decide how exactly should an event of this size and this scope and this intensity impact a particular human behavior. So we actually are working on a paper that just shows if I measure it differently, do the results change? And if they change, how am I supposed to measure this appropriately to, again, produce those accurate and defensible estimates for policymaking that I talked about in the beginning. Data on economic activity are relatively sparse, right? We often get county level information. Some information is only available at the state level, and it's often temporarily only available at monthly or quarterly or annual. So when I'm looking at the effects of an event that changes weekly or changes even daily or hourly, it's really difficult to tie those two together to look at a causal impact of the red tide on the human activity. We can collect data on human activity. Everybody's got these nice little cell phones in their pocket that collects lots of information about them, but obviously there's privacy concerns with who has access to that data. There's an exorbitant cost if I would like to purchase that data from some of the places that have it available. And if I can't get it or I'm not allowed to get it, then it's not really feasible to collect the information by a survey or by a focus group with people to see how human activity changed at a very small spatial scale or temporal scale. There's broader limitations when I'm looking at social effects. So not even just looking at how people change their activity or change their expenditure or purchase patterns. How do they feel about this? Like, how does it relate to their culture? Any of these things might also impact how they change their activity. And I had the chart earlier, I meant to put it back up here, but this influence on human activity on blooms and of blooms on human activity is bidirectional, right? And almost everything that I have seen or that we have done is looking at only one direction of that relationship. So it might be that we're changing, we know right now how human activity affects these red tide events, but the red tide events are in turn changing human activity. And then we need to see how is that going to filter out over time. So we'll go through a couple of results that we have. I think this might be the only one that I talked about last time that I was here a couple of years ago. But we've got a lot of results for Florida red tide, and then we've started moving into other types of harmful algal blooms that I'll show at the end. So one of the things that we've done is investigate the impacts of a particular red tide event, that one that happened in late 2017 through 2019 and lasted the entirety of 2018. on marine recreational activity. So this is one where we had some support from the West Coast Inland Navigation District, as well as the Marine Industries Association of Southwest Florida and Tampa Bay, to look at what was happening in sectors that there's not publicly available data on activity levels. So these are things like boats or jet ski sales, or the maintenance of those types of vehicles, boat storage, marinas, those types of things, as well as some of the for hire fishing and diving operations. We did 2 online surveys to try to get at some of this data. The survey content that we were asking about was, tell us a little bit about your business first. It's located, what type of practices do you have, the average annual revenues, because if you're going to look at a change in revenue, I need to know what's normal. The seasonality, so again, so we could tease out what part of your season did you get impacted by, if this lasted the entire year. And then we asked them, we had data on it, but we asked them about red tide presence locally during the 2018 event, because our data are not perfect either. When we looked at, and then we asked them about revenue impacts. So if you were impacted locally by the red tide event, what happened? What happened not only when it was present, but after it went away, or if you weren't impacted directly, what was happening to your business while red tide was affecting other areas. 90% of respondents indicated that red tide was present locally at some point during the event, during the entirety of that year. And then the average revenue changes were 61% decrease when red tide was present locally, about a 10% decrease when red tide was not present locally. So you're seeing that sort of geographic spillover. Even if you're not impacted, someone heard on the news that somewhere in Florida is impacted and may not engage in those water-based activities. And then there was still a 28% decrease in activity even after the red tide ended. So now we're looking at that temporal spillover of these marine recreation activities. And if I look at the average revenue change by year, they had a 2% decrease in 2017. The red tide didn't start until very late in that particular year, 27% decrease overall in 2018, which is, again, the red tide was present somewhere in Florida during that entire year. But still, it only lasted through January of 2019, and they saw a 9% decrease in revenue across the entirety of that year. And if that one just happens to interest you, we do have a report on our website where you can read additional details. One other paper that we published from that initial work, it was looking at the impacts to tourism activity. So again, going back to this idea of we need fine scale, spatial, and temporal data. One of the only things that we had related to tourist activity that was available at that scale was some information on Airbnb reservations. So we did some econometric modeling techniques to determine the impact of red tide on Airbnb demand. So that was not only looking at the number of reservations, but what they were paying for the reservations when they came. So what the ultimate result of this was that each positive test that revealed a concentration of that K. brevis organism at 100,000 cells per liter or more, it reduced what we call the average daily rate of Airbnb properties in a particular county by about 45 cents. So that's what you pay per day to that Airbnb property. And then it decreased the tourism demand for Airbnb nights reserved by 345 reservation days. So the numbers seem kind of small, but that's 45 cents in the Southwest Florida counties every time that a sample is detected. So it's not 45 cents for a particular day. And I often get asked, especially in those news interviews, does that mean if we sample more, the impact will be better? No. If we sample more, this 45 cents will be more accurate. It just means that might change. But it doesn't mean that just because we sample more, these estimates are specific to this particular red tide. Also, we talked about those broader economic impacts a minute ago, and this means that less people in Airbnb are spending less money on other things as well, right? So if they don't come, they're spending less money while they're there, they're changing the types of activities that they engage in. We actually see a decline in local visitor spending associated with those Airbnb visits of $184 million. And again, that's their spending. Now, the other industries that they're purchasing from are also spending less because they're having. So there's a little bit of a multiplier effect going on there that I don't. But again, if you want more information, there is a paper out in the Journal of Tourism Economics that you can see more information on that. One of the other ones that we're finishing up right now is looking at the impacts specifically on marine recreational fishing. So this in part was one component of the surveys that I talked about before, but we do have third-party data or data, publicly available data from NOAA that looks this marine recreational intercept program that collects data on marine recreational fishing specifically. Combine that with this harmful algal bloom monitoring database to look at how different modes, different locations of recreational fishing in Florida are affected by it. So again, we're using some econometric modeling techniques. This is a slightly different approach than we used in the former paper. But looking at the impact on the number of trips that recreational fishers are taking, but also the total catch that they're grabbing. So preliminary results here, and these I should have had my big red text at the bottom that says these are preliminary, not peer reviewed yet. So let's not take them to the policymakers to start making decisions. But preliminary results do suggest a decrease in the number of total trips that are taken during a month or wave when there's a red tide present. It's also indicating a decrease in the number of total catch during that when a county is impacted by red tide. And there is a difference in outcome across different modes of fishing. So if I look at a couple of charts that we've produced here, what you're looking at is across the bars here, red tide that's happening right now when the fishing is taking place, a red tide that happened last month and a red tide that happened 2 months ago. And then the top chart is all coastal counties in Florida are included in the data set. And then the bottom chart is just the 6 coastal counties in Southwest Florida that are most impacted by these types of events. And this is the point estimate and the confidence interval on that point estimate. So it shows us that recreational fishing trips decline during red tide events, but you'll see that only this one has that confidence interval not crossing 0. So there's no statistically significant impact on recreational fishing when red tide occurred 1 or 2 months prior. But there is when it's occurring during a particular month, and that's about a 10% change in the average number of total trips. These counties. When we look only at these 6 coastal counties in Southwest Florida, we see that the impact on the number of trips is larger. Now we're seeing about a 20% decline when the red tide is present, but again, it doesn't persist 2 months. And I'll just note that one of the reasons that we looked at these 6 counties is they experience these often than the other coastal counties. When we investigate the difference between different types or different modes of fishing, we separated them into what's called shore mode. So that's someone that's either standing on a pier, standing on the beach, standing on the shore and fishing from the shore. And non-shore mode, which is everything else. You took your private boat out, or you hired a charter boat, or these big party fishing boats. Everything else is considered non-shore based. And again, similar type of results that we're looking at in the charts, but the shore-based recreational fishing trips show no decline to the red tide events. This could be in part because they know that they can move just a little bit and not be impacted by the red tide when it's present in one part of the county, but not another. And it also might be that these tend to be offshore events. So it doesn't often come all the way inshore of an entire coastline. And they don't change where they're going or the amount of trips that they're taking. When we look at non-shore mode, these non-shore based recreational fishing trips decline. They do decline during the red tide events. So again, that includes all types of non-shore fishing, but you see it's even more than 20% decline in these types of recreational fishing trips when a red tide is present in particular. Last thing we were investigating is, does this persist? So now we're looking at just those 6 coastal counties in Southwest Florida and only that non-shore fishing mode that we know to be impacted. And now we're seeing there's red tide during month T, But as we go down, the red tide has lasted for at least 2 months, has lasted for at least 3 months, has lasted for at least 4 months, and so on. We stop at 7 because we lose the ability, we don't have enough data points that experienced red tide for 8 or more months. 8 or more months to be statistically significant beyond that 7-month mark. But you can see that none of these cross that 0 line. So now we are showing that these declines in non-shore based recreational fishing trips increase with the duration of the red tide event. And so it gets worse and worse the longer the event goes on. Other things that we're working on that I won't show detailed results for yet because they're, I'll call them preliminary, but some of them are getting close to us being confident enough to start presenting them. Commercial fishing, we looked at recreational fishing, but commercial fishing can also be impacted by these events. We've heard anecdotally that people have to drive further, go to a different location to catch fish, maybe land them in a different place that costs fuel. So one of the things that we're doing is focusing on key species groups that are caught within state waters, so or they have landings from being caught within state waters. And our preliminary, the reason we're doing that is because that's the majority of these trips in Southwest Florida, and also that's where these events tend to have the most impact on human activity and on economic activity. But our preliminary results here suggest that the stone crab harvest is impacted by these red tide events, and that's one of the most profitable, or at least most revenue generating types of landings in the Southwest Florida. We're also looking at property values in Southwest Florida, so you can guess that if these are naturally occurring events, they keep recurring more often, and potentially they're being impacted by human activity. You can make changes in some of these long-term decisions, not just do I want to go to the beach today or not, or do I want to go fishing today or not, but do I really want to own a home in a place where I heard about red tide this month, or I heard about red tide last year, or am I willing to pay the same amount that I would if I didn't hear about that? So we're investigating the impacts of red tide on residential property sales in the Southwest Florida area. This is using data from Zillow's Z-Trax program, which is now shutting down or close to shutting down. And so we're exploring other data sources for this to continue in the future. But we've at least wrapped up what we've done for now. And preliminary results suggest here that the spatial extent of the impacts that we see, or the declines that we do see in property values for the sales transactions, are limited to properties within about 250 meters of the coastline. So it doesn't seem to be extending further than that when we see these declines. The negative impacts are present during when the sale occurs during an ongoing red tide event, but they are more pronounced, again, similar to the fishing, the longer that event has been going on. And there is heterogeneity in the impacts across different property types. So we do see that single family homes are most impacted as opposed to some of these other types of condo purchases and things like that. And one other piece that we're working on is canceled recreational trips. So not just looking at those fishing trips, but anecdotally, again, we did hear that people from out of state were canceling a trip to Florida that they had planned because they saw in the news that their red tide was ongoing, or especially if they had respiratory illnesses that would make the impact of even a not severe red tide event more harmful to them. So they're changing locations, or they're coming, but they're not engaging in outdoor activities, or they come to a different part of the state as opposed to going to the beach. We did 2 surveys here to look at, to investigate those impacts on behavior of both the non-Floridians, so the ones that are coming and bringing new money to the state, but also the Floridians, to see how do they respond differently when they're going. They live in Orlando and they tend to go to the coast for their vacations. We do see trip cancellation and risk avoidance behavior in both of these groups, with differences in where they choose to go for their alternative locations, as well as the types of avoidance behaviors that they engage in across non-Floridians and Floridians. And so this has been an interesting piece of research for us. Again, we also expect that at least for some of these, there will be broader regional economic impacts of these changes. So if bunch of new money is no longer coming into the state from visitors, tourism being one of the top things that we specialize here in Florida, that's going to be an issue. And so we want to capture not just how many trips are they canceling, but how much money are they not spending because of the red tide. Okay, so that wraps up everything that we've kind of done on red tide, but we started to branch out and look at, because we do things on red tide, people started to contact us and go, oh, we have brown tide in Texas. Can you help us estimate the impacts of brown tide in Texas? We've been contacted, but not started any projects on looking at these sargassum outbreaks in Southeast Florida. So this made us kind of step back and focus. We can't do the same thing in the same ways that we do for red tide, not just because the data are different in Texas, Florida, but because these HAB specific, there are HAB specific pathways of impact, right? So I need to know, I know on a red tide, we discussed how that impacts somebody, but if I'm looking at brown tide, I need to know what is it harmful to, right? Or what is that effect on the humans directly or on the environment that affects the human activity related to it because of that specific type of harmful algal bloom. I need to know how harmful it is, right? Is it toxin producing? Or is it light nutrient limiting, affecting what's going on in the natural resource that you're engaging with? Or is it just ugly and stinky and people don't like it, so they tend to avoid it? And then again, this question on how do humans react to a particular type of event? Do they engage in these avoidance behaviors where they completely avoid it? They don't come at all to the area, or do they partially avoid it where they might not go to the beach, but they'll still eat at the beachfront restaurants, those types of things. Do they mitigating behaviors? Do they wear a mask if they might be affected by respiratory toxins? Do they not change what they're doing at all? This is also a possibility. And all of this will be dependent on their individual risk perceptions and risk preferences. So you might be willing to engage in more risky behavior than I am just generally, and you might have a different perception of how dangerous is this particular harmful algal bloom to me. So it varies by person. So brown tide, we did investigate brown tide in Baffin Bay, Texas, and it was very different and a very different type of project to work on. The effects of this harmful algal bloom are different than red tide, so it's not known to be toxic to people or other organisms. The exception is larval fish. It can affect certain fish species when they're in that stage, but it does reduce water clarity, which is harmful to seagrass. It can make fishing difficult. So through that pathway, it is impacting what's going on, especially with recreational fishing in this area. Regional characteristics are different. So Baffin Bay is very different than something like Tampa Bay or Fort Myers. It's a popular destination for recreational fishing, but there's not all of the buildup in terms of tourism activity along the coast. The nearest city is not there, and they're not staying in Airbnbs right near the beach either.
So you guys should remember Baffin Bay from like 2 weeks ago, right? We had hypermicro wet, so we didn't know that we are gonna make that connection, but
There you go.
okay.
Most of the land are used for agriculture and cattle ranching. And the fewer major population centers in the region compared to the Southwest Florida that we were focused on for red tide. And then also the spatial and temporal characteristics of the events are very different. So when we first started to say, well, can you give us the water quality data so that we can determine when the brown tide was present? We said, we kind of have that. They didn't have the type of duration or data quality that the Florida Fish and Wildlife Conservation Commission had, and we were initially just given, this is about when it happens. And we noticed, oh my gosh, that's a 7-year event, right? Like, this is not like a red tide where it's changing. But some are shorter, some are longer, some are lasting very long, and it's really hard to match those up with human activities. Result of that project was could not find a conclusive relationship. So there was an inconclusive relationship between recreational fishing, which is the only activity that we had data to examine, and these brown tide blooms. But again, anecdotally, they would say something very different. So it's a case of it's possible that we just don't have the data quality or the methods refined enough in order to tease this out. If we normally would. Speaking of even different, now the last thing that you might have seen on the news recently is this sargasm bloom that's out in the Atlantic Ocean and potentially coming for both the Caribbean and Florida beaches. It's not a new problem. It just happens to be a much larger bloom this year than people have expected. But this one is not a harmful algal bloom. So it does not produce toxins in the way that the red tide events do. It provides habitat for ocean life. It's naturally occurring and doing good things when it's out in the open ocean. Photosynthesizes to produce oxygen for ocean life, but it can still impact human activity. So this is a picture of the beaches down in the Miami, Fort Lauderdale area already experiencing some of that sargassum coming to the beach, and they're expecting it to get much worse in June, July. So here, if you see it out in the water, while you're engaging in those beach going activities, then it can harbor ocean life like jellyfish or other things that could cause skin irritation if you happen to be wading in it. And then on the beach, it's just stinky and unsightly. There's a lot of efforts to remove it as it gets there. Changes in behavior, anecdotal, again, these avoidance behaviors. The beach is ugly, I'm going to go to a different beach, or making changes in your activity choices. Maybe you eat at the beachside restaurants, but you're not willing to trudge through the 10 feet of sargassum to get out into the water. And removal does take place. Removal costs money, and they need a disposal location and a disposal plan for these large amounts that they're having to rake off the beach. And yeah, again, we have not done any formal analyses of these, but it's something that has come up even back in 2018 when it was slightly larger, but it is something else that we could investigate. That's not even a harmful algal bloom, but it is something that's impacting economic activity. So conclusions on the complexity, the dynamics, you guys know this, of marine, estuarine, and freshwater systems and their connections to the human system, and to HAB event that makes determining the effects of these HAB events or the impacts of them, the solutions for these events, what we might call wicked problems. There's multiple stakeholder groups involved, different agencies involved in water related decisions. And this creates potential conflict over desired outcomes or the means to achieve them. Might be power relations in place or that have been in place for a long time that make change difficult. There's uncertainty about the impacts of action. We all have modeling uncertainty. We have uncertainty in the type of estimates that we're producing as well. But accurate and defensible estimates of these socioeconomic impacts will require data collection efforts at multiple spatial and temporal scales. That's both for that biophysical data as well as for the economic data. And that's going to take interdisciplinary and even subdisciplinary collaboration to come to conclusions that are useful for informing policy making. That's all.
All right, that's cool. All right, we'll take questions in the room and I'll see if we have any from Zoom or YouTube. So let's start in the room. Questions for Dr. Court. Shayla.
Do you have any pushback from any like agencies that are within, like, because you're finding out the impacts or like studying it, like, or the kind of like, hey, it's natural, leave it be?
Not necessarily from agencies, but we have heard it. So often it's usually pushback from they want more information, the type of information that we produce, because they want to be able to say, we've seen the influence of media or social media to kind of impact activity that's not happening in a place where the red tide is happening. So they want to be able to dial that back down. The thing that they have more pushback against is forecasting, right? So if we try to forecast where the red tide will be or how intense it'll be out in the future, and then we're wrong, it might impact activity more than it would have if we let it naturally occur. So I would say not, I haven't heard it from the agencies either way. They're often the ones funding this to try to get more information, but it is often industry stakeholders or even general public that engages in these activities being concerned that if that modeling uncertainty or the uncertainty in the forecasts, it's the best thing to be advertising that there might be a red tide.
Have you ever thought about gathering information about behavior from like either social media or maybe like word of mouth, maybe like, is there anything like that? I know that it won't be as hard data as like simple if people are like with Airbnbs, like if if things are canceled or not, like, I'm pretty sure that's much more like hard data. But like, have you like considered that? Because I know that, I guess like with Twitter in particular, that one really like blows up whenever there's any sort of issue.
So this is the reason I have graduate students and collaborators, right? But collaborators, because we do surveys that I mentioned, and we do interviews and focus groups with local populations to try to learn what is the knowledge level and also what can they tell us about those anecdotal impacts that they've heard of. And graduate students is not tech savvy enough to scrape the Twitter data or to scrape these, but I have heard about efforts that look at like Flickr accounts and just see the pictures and take that information in as well as what they're talking about on social media, whether it's Twitter or Facebook. Or anything. So I know it's possible. We haven't done it only because I don't have the expertise to do it.
So Kathy and then Mark.
Do you have any sense of what's the impacts on
I don't, I'm not off the top of my head, but we are involved in discussions at the national level that includes Caribbean countries, so looking at not only red tide affecting us, but other types of harmful algal blooms. Because there is national level efforts to move forward on lessons related to mitigating the impacts. Oh, there is research ongoing. I don't know how it compares to what.
Mark.
So regarding that last point in your conclusions, which is the limited data, do you have plans to do some sort of a networking or like, would you have that subset of data that you would want to get that you always have to hindcast or, afterwards, but could you, and maybe you can't do it everywhere, but could you have like sentinel locations based on the types of either, HABs or, kind of the coastline that's going to get, or likely coastline that's going to be impacted by Sargasm, so could you kind of a priority start collecting that data?
Yeah, probably could. That won't be free either. So if I have funding to do it, that'd be great. But we are again, similar to the last answer, in discussions with the people that could fund things like that to say if I was the queen of the room and wanted this particular data, how can we get our hands on that? Because it's going to be critical to making what we're currently doing more accurate, but also being able to investigate other types of impacts.
And how long would you have to collect that data to have kind of a control group that didn't have the impact versus the period of time?
Yeah, I guess it depends on how often the event happens, right? We had this great period of a 10-year drought of hurricanes right before I got here. So we've got great baseline data before a hurricane hits, but these things are happening every year. So it might be that we've already reached a place where we're not going to get a control group without any red tide for a very long period. But it's all we can get, so it'd still be better to start with that.
So this is sort of like a philosophy of science question, but you showed like a few graphs that you showed. I think they were Vegeta made, like with the dot and the long bars, right? And you say, well, we can only say that there was a significant decline in number of trips or revenue if the confidence intervals don't cross 0. But you have so much variance, right? And you have anecdotal understanding of the impacts. And so, I mean, and then in Texas, you said, well, they're sort of like not really supported, but do you feel like you're obviously being very rigorous about saying statistical significance or not, but I guess, do you feel like you could give yourself a little bit of room to say, well, there was a decline and it was like not being statistically significant, but there's still there was a measurable decline. It's so variable. The data are so coarse that you might just take a different, more like narrative approach to displaying the results.
Yeah, and I think that's kind of what we do with what we're learning with focus groups and other things as well. And I often tell people, I can't prove it with the data, but everyone is telling us that it's impacted, and everyone's telling us that it lasts longer than the data are showing. So it's really just showing the limitations of the data that we have available to us if in every interview and every focus group, they're saying something different than the data are saying. So we do try to put those things together when we talk to a policymaker and say, so my data are showing, but here's what else that we're hearing. And here's what might be a data limitation or a methodological limitation that's driving that result, not just the relationship in there.
Yeah, and it might even influence, so your bars are 95% confidence or whatever, and you may say, well, if I have tons of anecdotal evidence, I may just choose to use 90% confidence bars, and like, if you set that up ahead of time, you're not like hacking your p-values, but you're supporting it with no information.
Yep.
Any other questions?
And just while we have students in the room, the discussions that you have with a policymaker are very different than the discussions you have with an academic or a general public audience. So should definitely consider your audience.
I have one question from Jason on Zoom. He says, is there a potential indirect beneficial effect of HABs that the state's legislature and administration are much more interested in providing funding for water quality? Go ahead, can you unmute and can you ask this question, Jason?
Hey, thanks. It's just interesting. It seems like everyone's much more interested in water quality research and monitoring when things go horribly wrong. And maybe this is in a way, it's like finally people are paying attention. And so that might be one good thing, although it's small consolation.
Yeah, and I'll tell you that most of this funding came when things were going horribly wrong in 2018, right? And we've seen significant amount of funding in the socioeconomic impacts since then, but I expect, like everything else, when it's kind of out of sight, out of mind, it might drop off. So we hope that doesn't happen, but yeah, we're definitely a reactionary species.
Right. Thank you. Thanks for doing this talk.
All right, one more round of applause for Dr. Ford.
Did it bring some handouts if everyone is interested in all the other folks in our department that are doing water related research and the type of things that they're doing in case it's helpful?